A nuclear submarine is the most complex machine ever built. 111 meters of steel surviving 300 meters of crushing ocean pressure. Within that hull, engineers must balance two high-stakes systems: a nuclear reactor that must remain stable at all times, sitting just meters away from ballistic missiles designed to launch through the water column. The difficulty of this integration is reflected in the global landscape. Before 2009, only 5 nations had the industrial infrastructure and technical knowledge required to build a functioning nuclear submarine. This is the INS Ariant, the vessel that made India the 6th nation on that list. Its completion established India's nuclear triad, a 3-pronged military force of land, air, and sea-based weapons, providing a second strike capability that ensures the nation can retaliate even after a surprise attack. Success required more than just scaling up existing technology. Indian scientists had to develop ways to miniaturize a massive power plant, propel rockets through the ocean, and eliminate the acoustic signature of thousands of moving parts. Land-based nuclear power requires immense physical space. This containment dome illustrates the footprint needed to house a reactor and its safety system safely. Researchers spent 2 decades compressing an 83-megawatt thermal plant into a 10-meter hull. They utilized a compact pressurized water reactor, heating water under extreme pressure. This heat transfers to a clean loop, spinning turbines while keeping radioactive coolant completely isolated. This closed-loop system is the reason the submarine can stay submerged for decades, restricted only by the food supply for the crew rather than fuel for the engines. Tucked behind the sail are 4 vertical launch tubes. These can house K-15 missiles or the much larger K-4, which has a reach of 3,500 kilometers. Launching these from depth is a physics challenge. You cannot ignite a rocket motor while it is submerged, yet the missile must reach the surface quickly and reliably from 60 meters down. The solution is a cold launch. A generator shoots high-pressure gas, ejecting the missile inside a protective dry bubble. As it breaks the surface, onboard sensors detect the resistance change and immediately ignite the solid rocket motor. This entire sequence, from the initial trigger to full flight, takes less than 10 seconds, forming the core of India's strategic deterrent. In the deep ocean, acoustic stealth is a survival necessity. Because sound travels for hundreds of kilometers underwater, any mechanical noise can give away a submarine's position. To counter sonar, the hull uses anechoic tiles with tiny voids that trap and dissipate sound energy. Internally, the 600-ton propulsion system sits in a shock-absorbent titanium shell, preventing engine vibrations from reaching the outer hull. While it remains silent, the Arihant uses the Panchendria system to listen. This sonar suite uses 5 different detection modes to track threats across entire ocean basins. These systems turn the submarine into an apex predator, a machine that can hear every ship in the region while remaining completely undetectable. In 2017, a simple human error nearly destroyed this multi-billion-dollar asset. Corrosive seawater flooded directly into the Arihant's propulsion compartment. The salt water reached the specialized pipes that carry the reactor's pressurized coolant. These pipes operate at 150 atmospheres and cannot tolerate any structural corrosion. Repairing the damage required a surgical industrial process. Every affected pipe had to be cut out and replaced to ensure the reactor could operate safely under pressure. The timing created a strategic crisis. For 10 months, India's primary sea-based deterrent was stuck in dry dock, exactly as a major military standoff with China was unfolding at Doklam. 3 decades of precision engineering were nearly undone by an unsealed hatch, a stark reminder of how vulnerable even the most advanced machines are to basic human mistakes. The Ariant returned to service in November 2018, completing a 20-day patrol that confirmed the repairs were successful. By returning to full operational status, the submarine proved that India's second strike capability was a functional reality, not just a laboratory concept. The Ariant served as the foundation for an expanding fleet. The INS Arigat is now operational, and the follow-up vessel, the Ari Daman, is designed with double the missile capacity. Somewhere in the Indian Ocean, a 4th, even more advanced boat is currently undergoing sea trials. By mastering the complexities of the deep, India has secured its presence in the ocean, ensuring its destroyers of enemies are always on watch.